This is the fourth video that I'm putting together that has to deal with the use of Flir tools to perform thermal image analysis and thermal tuning. In the first video we activated software and loaded in our files. The second video we found reflected temperature in a given area, and then the third video I was able to find the emissivity of the surface finish, the gray finish of this box, by comparing it to the black piece of electrical tape here, which is a known emissivity of 0.95. We ended up finding an emissivity of 0.9. And so this is where we left off. We had our measurement boxes. Now we know that our emissivity is 0.9. Now we can perform what's called thermal tuning and image analysis. And so one of the things I did kind of at the end of the last video is I created a box measurement covering as much of this as I could, but making sure not to include anything in the background. And from that I looked for my min and my max. I got rid of average. And so this is box 5 I just created. In box 5 it's showing that the minimum is about 97.2 degrees Fahrenheit. The maximum is about 108.8 degrees Fahrenheit. And so what we can do is we can use this to perform thermal tuning on the image and try to bring out some more detail of what we might see. So now that we know, our emissivity is 0.9, I don't have a use for these other boxes anymore, or to the same extent, so I can actually remove them if I want to kind of get a better idea of specific features of the box. So what I'm going to do is uncover them. They do go in order, so I'm going to delete each of these. If I click on them and just hit the delete key. But I'm going to leave my box 5 for right now. And you can see box 5 is still shown here on the right, 108.8, 97.1. The emissivity we had was 0.9. I'm going to leave that in there. We found that in the previous video. Reflected temperature 78.1. This image was only taken from a short distance away, so distance, consequently distance, atmospheric temperature, and relative humidity, their impact is going to be very minimal, and we weren't using external optics, so those are going to be, with this left at 1, the external optics transmission at 1, it's going to negate out the external optics temperature. So with our box we can see it's 197.1 to 108.8 degrees Fahrenheit, and so now we can tune it in. You can see right now our temperature range goes from 77.3 at the low end to 107.1 at the high end. And so what that means is at the low end we're showing a bunch of extra temperatures that really aren't going to help us perform analysis of our box, which is our target piece. You can see there's an area down at the bottom here that's kind of in pink and purple. That's the table that this is sitting on, and so we're not worried about the table in this instance. And so what we can do is bring our lower bound of our what's called our range, our temperature range. We can bring that up, and you can see as I drag this to the right, the lower bound is given in this box right here. As I drag this slider to the right, that number goes up, and you can see more and more of the background kind of drops out, but there's still the box there. We're still seeing color on the box. If I bring it up way too high, you can see parts of the box start to disappear as well. And I'm going to actually go out of MSX view. I'm just going to look at a pure thermal image. That's what we're most concerned with when we're doing this. So I did that. That's these images up at the top. The one you want to use for true analysis is this true thermal image right here. You don't want to use MSX, which has a visible image overlay. You don't want to use thermal fusion, which is another type of visible image overlay. Same thing with thermal blending. You can see there are just different ways of looking at it. You can do a picture-in-picture where there's a thermal image in the middle, or you can look at just the digital camera. But we're most concerned with the thermal image. That's this one here. And so our minimum in that box is 97.1. Now I want to make sure I don't miss anything, so I'm not going to quite go up to 97.1. I think I'm going to start at 95. And I can kind of look at it. There might be a few spots in the top right here that are a little bit cooler than that. I can kind of bring my box over and see if I get anything over there in particular. Yeah, see that top spot, it's showing 96.4, so still within the range that we did. But maybe I'll take this down to 93. Okay, that's going to be our low end. Now at our high end, you can see this middle area is very white hot, but it doesn't tell us a lot about it. This gets 2 in the middle here. It's very washed out. We can't see it. Part of that is because it turns white when we exceed the top end. And our hottest point, this red triangle right here, is our hottest point is 108.1. But right now our scale tops out at 107.1. And so we need to increase the upper end of our range in order to be able to include that. So I'm going to actually bring this up to 110 for good measure. Maybe not quite that far, maybe go 109. I liked 110 better. And you can see this is subjective. This is, do you like it, do you not like it? But now what we've done is we've performed thermal tuning where we can see in detail our box, and we've gotten rid of all of this in the background that wasn't important to us. Some other things we can do while we're in here, I'm going to go ahead and save my image real quick. But other things you can do, we can look at colors. Sometimes different, what are called color palettes, have the ability to bring out additional detail. And so I don't even have to, so from image, this top one, that's what it was originally taken in. However, I can hover over these and you'll see it's going to change the different palettes that come up. You can do a grayscale image. You can do different iron as a high contrast. Lava is another you can see very high contrast image. So it's rainbow. And so sometimes you can use some of these to get a better understanding of where the different temperature gradients are. In this case, where the hotter areas and colder areas are. So you can see there's a big, if I use this rainbow, what's called rainbow HC, HC stands for high contrast, you can see a much more dramatic difference between temperatures where we're directly inside. There's a light bulb inside of here. The center part is the light bulb is directly behind this part of the metal, this piece of the metal. And then as we travel outwards, you can see it's a lot cooler, especially at the very bottom corners. But then also the lid, you have a lid here that overlaps. There's a layer of metal, and then it's kind of like a shoebox. You can see where this overlaps right here. And so that overlap, there's not as much heat transferring through it. And so you can see the dramatic difference there. So we can use this to try to find different things. And so the way why this is important is because there are times where you can use this to perform image analysis to try to find some of those subtle differences in an image or in a material. Subtle differences that could be caused by damage. Things like delamination, impact damage, moisture ingress, and that kind of thing. And so that using some of these different things is good. Another option we have when we're thermal tuning is we can set what are called alarms, thermal alarms, and those are in this color palette area as well, and they're down at the bottom. And you can set alarms for areas that are above a certain temperature where it'll only color the image above or below. You can do an interval. You get a top and a bottom boundary. There are humidity, if you have equipment that can do humidity levels, or if you're looking for moisture ingress, you can use that, and some other stuff like that. So for instance, above, we could say if we had an object that had a max temperature of 100 degrees, I can go to my alarm coloring over here. I can say limit is 100, and so anywhere that's above 100 degrees is going to be colored. Maybe we can say it's 105. So now you can see just the areas that are 105 degrees or more. You can change the color. Doesn't really matter. Red tends to be used for high limit because it's hot. We can also do a cold limit if we want. So if we're below, say we want like a cylinder, we know normal operating temperature and we're looking for cold cylinders. We could say if it's below, anywhere that's below 100 degrees. So the only places it's coloring right now are, you can see the lid of the box as well as the background. You can see the whole background turn blue because that's that is below 100 degrees. Or we can do an interval, which is between a range. So if we say normal operating temperature is between 100 and 105 degrees, we can look at what areas are cold, or say 101. Let's see if we can get maybe 102. There we go. To 105, you can see the areas now, the things that are colored, that are in this yellow, are just the areas that are more than 102 or more, but still equal to or less than 105 degrees. Okay, so these are different ways to perform image analysis in order to try to find certain features of a part.